Welcome everyone to Driving Operational Knowledge Through Drones. This is the second webinar in Esri's National Government webinar series. My name is Noelle Loughran, and I'll be kicking off today's webinar. Our key objectives for today's webinar are exploring the power of drones for GIS, implementation basics, sample use cases, and Esri drone offerings. If you have any questions, please feel free to drop them in the chat. We're also recording this webinar today, and we will send a link out to everyone that has registered. And if you have any additional questions during or after this session, my email is right there on the bottom corner. So I'd like to introduce today's speakers. Again, my name is Noelle Loughran. I am on Esri's National Government team, and I am on the marketing side. We also have Ben Conklin. He is the Director of Defense and Intelligence Solutions. We're also lucky to have with us today Will Shewart. He is with the Virginia Commonwealth University. We have Kyle Talbot from the imagery team. He is a solutions engineer here at Esri. And we also have Jeff Taylor from our imagery team, also a solution engineer. And before I pass this off to our speakers, I would like to start us all off with a polling question. So you will see on your screen in a few moments, what is the status of drone use within your organization? And please feel free to select any one of those. We will give all of you a few moments to respond. All right, thank you for participating. I will close this and I will share our results. So it looks like a majority of you have a limited program underway. Well, we really hope that what you gain from today's webinar will help set you on the right path if you plan on expanding that. And so without any further delay, I would like to pass this off to Ben Conklin.
Thanks a lot, Noelle. So hopefully the opening video gave you some ideas and maybe inspiration around the use of imagery as part of ArcGIS. As Noelle mentioned from that poll, we see that many of you are maybe in the early days of integrating drones and imagery into your workflows. Maybe you have some more traditional aerial imagery and satellite imagery being managed in ArcGIS, or maybe you're even new to imagery in ArcGIS. And it really all starts with that data, bringing in remote sense information and data, bringing it into cloud or on-premise storage, providing workflows like photogrammetric workflows, ortho mapping, et cetera, improving the quality of the data, creating derived products from that data, and then serving it up and making it available to a variety of applications, both on the web and in the desktop, and to be able to perform analytics on that data. And these processes are true for all types of imagery. So what you're going to see today is all about drones. But you can actually apply many of these same processes and workflows to other data. What I'm really excited, though, about is really the power and the potential of drones. And as Noelle mentioned, I manage our defense and intelligence industry. I'd say for a long time, we've been interested in things like UAVs and other more exotic unmanned vehicles. But actually, what we've seen over the last few years is this explosion of consumer level drones and drones that are really powerful and capable and can be used across many workflows, across many different industries, across national government, helping you take imagery and turn it to meaningful information and helping you be able to quickly map and create high accuracy products. What I'm really excited to do is actually start off by diving into a very specific use case example around some facility management applications. And we're really lucky to be joined by Will today from Virginia Commonwealth University. He's going to take us through a couple things today, but the first one is going to be a pretty awesome example of how to use drones for facility management applications. And with that, I'll turn it over to Will.
So my name is Will Shewart, and I'm an assistant professor here at VCU in Richmond, and I'm going to show you a few applications of drone technology using Esri solutions that you'll see throughout the rest of the webinar from my colleagues Jeff and Kyle, and they'll go into deeper details. You probably already have some ideas on how you want to integrate drones into your programs. One could be natural or cultural resources and inventories, and here's a project right here. I've acquired drone imagery for several historical landmarks in Richmond, this one being General Robert E. Lee Monument. And this was a series of drone flights that I did to create this model. Monument Avenue is a historical street. It has several monuments, and you can see here from the elevation model and the orthophoto, the imagery and the products that you get are very compelling. And if I switch over here to the 3D mesh, in Drone to Map, the mesh and the point cloud came out really good. And it also captured areas around the monument. Most of these homes are very historical. So not only do you see the monument, but you also see the context of where the monument is. And just to show you a little bit further here, that's what the monument looks like on the left, the picture, and the 3D mesh and point cloud. And so as you can see, they look really realistic compared to the photo because of the ways the imagery was collected using different angles and, of course, good processing. Another application here is a World War I monument in Richmond. This is the Caroline, and this is a ground control point that you see here, but this is the orthophoto. You can see you can get very high quality imagery and imagery products. There's your digital elevation model and your digital surface model, and then the 3D mesh rendering here. And if I sort of fast forward here, you can kind of see also the context and the surrounds of the monument. This is another 3D model of that, looking at the elevation point cloud and the mesh together, so you can kind of see how that looks. And then of course you have the photo on the right of what it looks like. That was taken a few weeks ago. So really cool area that you can go walk around, and so you can see you can get a lot of good information there. So you may also be embarking on a pretty large project that you want drones to be a major contributor in. This is an 1,100 acre reservoir that's being constructed just to the west of Richmond for several areas, and there was 1,680 photos or so collected that I used in EBX for, SenseFly EBX, and you can see the digital surface model and control points here. And now if I sort of switch over here and we look at the 3D mesh and LAS point cloud, you can see there's a lot of detail there, and you can do volumetrics and things, and you'll see that later on in the presentation. But there's your photogrammetric point cloud and the mesh. They look really good. So it could be for erosion control, site assessment, things like that. There's a variety of reasons why you might want to do that, but it's a pretty massive project. You might have a facilities project that's just really hard to do a traditional survey on. This is a steam plant. They're actually putting a building right where that parking deck is, and there's an elevation drop of about 80 feet or so. And so you can kind of see that that's a tough position, but for a drone, provides another way to acquire data that you can integrate into CAD and other types of modeling with. You may have a site that you're doing a capital project on, you want to monitor progress. That could be soil removed or allowing a public to see different phases of construction. Here I've got two flights here, both processed with and without ground control, which I'll show you here in a second. So if I sort of move through this here, this is a drone data set that was acquired on May 7th. and then another one on May 18th, yesterday as a matter of fact. And you can kind of see here, this is without ground control. You can kind of see these don't necessarily line up all that well. And so if I process this with ground control now, sort of move through here, now you can kind of see that I've got my ground control in there and the two data sets overlap, and you can look at change between the 2 weeks, which obviously there was a lot of change between 2 weeks. But this provides a lot of insight into projects, especially ones that you have to head over and provide additional details on. And so now what I'd like to do is you can also download those into your ArcGIS Pro environment, and you can do some 3D display of those two side by side. So you can kind of look at the differences between the two as well. You can also publish those to your enterprise portal for mass consumption. And at this point, what I'd like to do is turn it back over to Ben, and he can focus a little bit more and provide some context on the Esri drone collection itself. Ben?
Great, thanks. Thanks for that. So I think hopefully you got there from Will's demo is a pretty impressive collection of amazing information products and data sets that he's able to create, all from drone collections using the same tools that we're going to be talking about going forward. And we will dive into a little more detail about how to get started with these tools and what they all are as we get further to the webinar. So if you couldn't keep up with all of Will's amazing examples, you'll get to see how you can go accomplish some of those on your own projects using ArcGIS drone collections. So really fundamentally what we're seeing, and I think you saw just so many examples of Will's, is that drones are providing this new window on the world. And what fundamentally is happening is drones are helping us create highly accurate maps very quickly with low cost and high quality. That means that we can create maps and data products that are current in time, they're really recent. As you see there, that idea of taking a project and actually resurveying it in a couple of weeks, those kind of concepts would have been cost prohibitive in the past using more traditional platforms. And so really we can use this capability to increase our knowledge of our area over specific geography and facilities. And drones, of course, really focused and high resolution over very small areas, giving us that high resolution data. And then we can integrate it in with other larger scale collection projects. And the key really when we think about drone operations is its ability to integrate in all the complexities around drones. And there might be different types of drones, different sensors, planning flights, dealing with problems like how do we share our content? How do we create our content? How do we deal with rules and regulations around managing our fleet? And really what we're trying to do here at Esri is help simplify this and help make it easier for you to be effective immediately when you have that drone for your organization and you have the project that you need to tackle. We have a lot of tools to help kind of reduce the complexity and make you more successful immediately. So when we think about drones, we really think about the kind of products that they create, and they fall into basically three primary categories. Two-dimensional image maps, so accurate maps made from imagery that are stitched together, as well as digital surface models. We can also make 3D products, so that's to me, it's just phenomenal. The idea that we actually can create these high-resolution, amazing 3D products, again, that would have been prohibitively expensive to create in the past, and very, very difficult to create accurate products. So we can create all these point cloud data, mesh models, and site models. And in addition to that, we also collect, these oblique inspection photos, so being able to collect the actual photo as it was taken from the drone in the direction that it was taken from. So those types of products get translated into some specific information products that are useful in your GIS and can support a variety of different workflows. It helps produce some base mapping, so having higher resolution, higher quality, more recent base maps. It can help us model our sites with these kind of 3D data products, and then also can help us do inspections and measurements against this very highly accurate data. And speaking of accuracy, it's really about creating this authoritative data. You saw how introducing and using ground control helps us be able to create accurate products, as well as actually be able to assess the accuracy of our drone collection and understand the quality of the data, especially trying to do surveying, inspection management, and things like that, where we need pretty accurate measurement from the field when we're back in the office. So to start with, when we talk about drone collection, we start with drone to map. So drone to map's a proven product that's been used by users all around the world. We saw that it's used to create, can be used to create really amazing information products. It just requires a standalone PC application, so it can run on a laptop you take in the field. It helps you do photogrammetric processing on this data. It also integrates seamlessly with ArcGIS Pro, again, like you saw Will show us, as well as publishing your products to ArcGIS Online, which then enables you to share it out to everybody else in your organization. So what we definitely saw from the popularity and interest around drone mapping is that organizations really wanted to go beyond kind of processing a single drone collection of data, to actually be able to handle large fleets, run organizational operations, be able to handle large volumes of data, and scale out to basically leverage the power of the cloud to scale out the processing operations. So we've introduced the ability to handle all of this through our drone mapping collections, which really is a complete platform solution that leverages all the ArcGIS technology. And the way that we deliver that is through 4 different drone mapping collections that support either individual operations, as we've been talking about so far. So this ability to plan and capture data using SiteScan and doing flight planning apps, processing that data as we've always been able to do with Drone to Map, and then disseminating in ArcGIS Online. We can go from that single drone up to large scale online drone mapping and even enterprise drone mapping and analytics. And so that the scalability here really helps you decide what's right for your organization based on your needs and based on the scale of planning and operations that you want to do, and how elastic and flexible you need to be with your solutions. So when we're using drones, we have a variety of different applications that we can apply this drone collected data to. We can use it to monitor projects that are in process. So probably many of you, if you're working in government space, might be dealing with facilities or installations that are being maintained or updated, or maybe security plans are being rolled out and you want to monitor the progress of that. Or maybe you're thinking about the need to be able to quickly create maps after a disaster and be able to understand the damage without having to have necessarily people on the ground doing individual damage assessment inspections. You can actually use drones to help assist in that process, especially for hard to reach areas or denied areas. Maybe you're, again, responsible for specific facilities. So you want to create 3D models of those facilities, so you have accurate 3D models that you can use for a variety of different purposes, whether it's to do future planning or asset management. You can use it for land use planning, helping with inspections of infrastructure. So actually some of the great examples we saw Will would really help with infrastructure inspections, looking at managing and understanding use of natural resources, especially facilities and locations like hazardous material facilities where individual on-site inspections are difficult. Drones can help there. And then actually monitoring, preparing for, and running and measuring activities during events as well. Drones can help us with all of those activities. So now to get into some more detail around the specific drone collection, I'm going to turn it over to Carl Talbot, who's going to take us through this end-to-end workflow of leveraging these drone collections.
Awesome. So yeah, I want to start by showing some of our newer products. One of the things that one of the biggest items of feedback that we got over the past few years when showing Drone to Map was asking for a way to be able to do flight planning. And so with our acquisition of SiteScan at the very end of last year, we do now provide a flight planning application to be able to do a complete end-to-end workflow. So we're going to show how this flight planning app works. It runs in iOS devices like an iPad. And so when you open up your flight planning application, you can either create a new project or select an existing project. Now these projects are where your various drone flights are stored, so that you can organize them based on multiple collects over similar geographies, so that they're organized all in the same place. And so when you select an existing project or create a new project, you have an option to connect to various different drones. Your organization could have various different drones that you're working with, so you can connect to the right one. You can create new flight plans or select existing ones. So we're going to show you a flight plan that we used previously over this area. We can run the same flight from this existing flight plan again, or we can adjust some of its settings. So with simple slide technology that you would want on a touchscreen device. You can adjust the altitude, change the hatch angles, and even change the area that you're capturing. And it's done very easily. It'll automatically make those adjustments for you based on the patterns that you've chosen and the various inputs. It's smart enough to figure all that out on its own. So we'll show you creating a new plan. We showed a crosshatch the last time. This one's more of a perimeter scan, better for capturing the multiple angles required to generate 3D projects. So we can show here giving it a flight name. And once we create the name, it gives you your area of interest to set, the area that you want to capture. We want to capture this bridge, and so we can easily adjust the area that we're capturing to make sure we get that coverage. Once that's set, we can add an offset angle to see where we are, set that so that we capture it appropriately, and then we can even adjust the altitude settings so that we can capture the appropriate height above and around this bridge, and you can visualize that in 3D as well. So there are many different flight plans that you're able to work with in the SiteScan flight planning application, depending on what it is that what products you want to generate. Once you have your flight plan set the way you want to, you can go through a checklist process that you set up in your organization to make sure that your aircraft and your cameras, batteries, everything is going to run smoothly. And you can set it up in your organization so that this checklist must be gone through before you can take off. And then once your flight has been captured, the advantage of working with SiteScan in the cloud is that the photos that you capture can automatically be synced and uploaded into the cloud, even when you're out in the field, and then it will start to process automatically. So we'll now show you what that looks like. So this is the second part of SiteScan. This is what is known as the SiteScan Manager. And as you can see, I'm working with this in Google Chrome. This can be accessed in any browser. And it shows all of the various projects here in my my opening pane that I had access to in my organization. And you can see that this is something that is tied with my Esri org. And if you see under here, under the team members, you can see all the different members of this organization and their various roles assigned based on what they need to do. So some people in this org only have read access, others have full access or administrator access. I'm also able to manage my fleet here. These are the same drones that we were looking at in the flight planning app. Here we can fully access them, manage them. We can even manage the various batteries that accompany those drones. And then I can access all of the different projects. Now, as I said, you have the ability to create flight plans in the flight planning application, and then those photos, once they're captured, can automatically be uploaded here, and will start processing on their own. But you don't have to just use that flight planning app to upload photos. You can also come here and create a new project, give it a name and settings, and then if you have your imagery stored locally somewhere on a drive, that's where you're able to add that imagery and upload it and start creating these various products. So we'll show you a few different projects that we've been working on. So here, again, you can see in this flight of the Varzea, the Lopez mine, we have different flights that were captured at different times over this mine. So we can organize it and see the change that occurs between different flights. And I have to apologize, my internet is moving a little slow today. But as you can see, when we access this flight, you can see the orthomosaic that was generated from these photos, and we can turn on the photos and view them individually. But we can also see the products that that SiteScan generated, and as you can see, this this orthomosaic is much better quality than the satellite base map below it. 2D, we were also able to generate various different elevation products, so we can turn on things like contour lines that show very well in this mine, different hill shades, and elevation models. And it's generating those products both as DEMs and DTMs. In SiteScan, we have various different analysis tools for quick analysis. So we have a tool for measuring volume. And as we can see, when we generate a volume over this mound of dirt, we get those accurate measurements here, and we can even view and edit those measurements in 3D. So that's a 2D output. SiteScan will generate both 2D and 3D outputs for your projects. However, we're going to go back to the bridge that we were working with in the flight planning app, because the flight that we made for the bridge was specifically designed to be able to generate a solid 3D product from that. And so one of the things that we can generate is a point cloud, and you can see just how high quality of a point cloud we were able to generate from that. The point cloud provides various analysis tools as well. There's a tool that allows you to generate an elevation profile. So when I drop that point, I can measure from the bottom of the canyon to the top of the canyon and see what that profile is in this graph. And I also have a photo inspect tool that allows me to select any point on the bridge or anywhere in this point cloud, and then it will provide me all of the raw photos that point falls into, which I can then use for markups as I can download these photos individually. And then the other thing that we're able to do is overlay the photos onto the point cloud that was generated, and from that we can generate a 3D mesh and model that can be used for visualization. Give that just a second to load. So now we can see that seamless bridge. So we're going to open up one more project here. You know, we're pretty drone agnostic here. We're able to connect with various different drone types, sensor types. While SiteScan is definitely geared towards drone imagery that low altitude collects, we did want to show you this one project that we've been working with the Civil Air Patrol. This was actually imagery that we captured using a Waldo camera that was fixed to a manned aircraft, but it was flown at a low elevation to be able to mimic drone a drone capture. And this imagery was flown right after Hurricane Michael in late 2018. So you can see that flight pattern that was taken was very unique. But this imagery was captured to be able to identify homes and various commercial property that was damaged after the hurricane. And even from a manned aircraft, we were able to generate some very solid products from this. So this is software that is all available on the web, and it's software that you're able to connect directly to your ArcGIS Enterprise and ArcGIS Online organizations. So you can export all of these products locally. You can download them in the various file formats that you want, or again, you can connect to your ArcGIS organizations, and then you can share all of these products, generate them so that they can be accessed throughout the platform, whether that be in a web map or scene, or you can open them up in Pro or in various other applications. So you can see that the point cloud that we generated from the Mexico Beach imagery, we're able to visualize this in the web scene viewer in ArcGIS Online. So that covers our end-to-end drone workflow. And with that, I will turn it back to Noelle.
Thank you. So next we have 2 polling questions for you. First one is going to be a little bit of fun. So for those of you that are working from home, what have you enjoyed most about the experience? And you can select one or as many of those as you'd like. And we'll leave that open for a few minutes. All right, thank you for your responses. And I will share those right now. And I could not agree more. As soon as those responses are visible, couldn't agree more. Every day is Casual Dress Friday. I love it. Now back to work. Our next polling question is, and you should see that on your screen in a few moments, but we are interested in understanding what are you doing with your drone program? And please select any one of those options, and we'll give you a few moments to respond. Thank you for those responses. I will share those now. It might take a moment for it to appear on your screen, but it looks like it was pretty close. A majority of you were saying that doing change detection is something you're most interested in, and then in a close second is using elevation output to measure volumes or map the terrain. So the next part of our session should be helpful with guiding you through those things. And so I would actually like to pass this back to, or I'd like to pass this to Jeff Taylor now.
Awesome, thank you, Noelle. Yeah, I like all of the above of those questions. So in this case, let's jump into Drone-to-Map. And the key with Drone-to-Map is if you're going to be working off the grid, you're off the network, you can't have easy access to the internet to be able to upload and process data, you can use this anywhere. And just like you can use ArcGIS Pro in a disconnected environment. We're going to cover both of those really quickly. So when Drone-to-Map first opens, you minimize this, you arrive at this template screen where you can choose from project templates such as 2D rapid, 2D full, 3D mapping, or batch processing, or create or import your own custom template later. For this demo, let's choose a 2D full job and import the images stored locally on our drive. The green checkboxes on the left indicate everything showed in correctly. And it's best to also look at the X, Y, and Z location data listed to make sure those also came in right. Upon creating the project, the data is loaded into the map screen. And Esri provides many base maps for use in Drone to Map. You can change these base maps to imagery for better context. And the flight data includes these blue icons denoting the locations images were taken and an orange path known as the trajectory line where the aircraft was flying. You can view the raw images by opening up the image viewer, zoom in and inspect what's going on, use the carousel at the bottom to change the image, or select images using the blue icons on the map to the right. Using ground control is what we're going to go into next. So we can import ground control data using the ground control import wizard. This allows you to bring in the targets that you established during the collection. And you can see these represented in a second by green icons. Here's a list of all those ground control points. By clicking the options sprocket at the top of the screen, you can select the output settings and the coordinate system for your project. And when you're ready to begin processing the data, just click the Start button, and this will begin stitching together your drone images and create the products. Some of the products that get generated are true ortho mosaics. You can see that this is a true ortho, meaning that everything looks as if you're looking directly downward from overhead. We can also bring in the digital surface model, providing elevation information that can be used for analysis. We also generate something called a dynamic mosaic, which helps allow the visualization of the sides of features, which is different from a true ortho, where we are viewing from directly overhead in that case. As I can pan across the screen, you see the imagery dynamically update. And this is extremely useful for inspections, where you need to see more angles than just the typical top-down. Switching to 3D, you can visualize the 3D mesh and work with the point cloud that is generated from your drone project. So next we'll jump into this 2D map and conduct analysis. And if you want to estimate the volume of something like this stockpile, you can choose the volume tool located under the analysis tools and draw a polygon around the stockpile. This will estimate the cut and fill volume for the stockpile of interest. These measurements are then saved in the mensuration results tab to the right, where you can also measure distances as well as areas and perimeters, such as this building being shown. And sharing data generated in Drone to Map is easy using the Share tab, where you can easily share a tile layer, an image layer, or the entire web map to your ArcGIS Online or Enterprise account. Additionally, your drone project can be imported into ArcGIS Pro to access a wide range of geoprocessing and analytics capabilities. So, Esri drone collection software also supports the processing of airborne imagery, such as multiple angle obliques, in both Drone to Map or side scanner. So let's dive into how you can leverage this data in ArcGIS Pro. Firstly, we can add the high resolution drone collections ortho image to the base map. Note how much higher resolution this ortho image is than the default base map. One of the reasons we're flying drone imagery in the first place. Now let's improve the elevation quality. We'll zoom into an area we can see it. And we're going to add the digital terrain model that was generated. Next, we can turn on the 3D mesh. And with just a few clicks, we have a version of a digital twin. We can then go and conduct all sorts of real-time analysis on this, such as visibility studies, draw a point, change the view shed direction, and conduct that really rapid analysis. We can even add the LiDAR point cloud data. In this case for drones, it contains color values automatically. And Esri provides a suite of tools to help support classifying this data. With point cloud, you can visualize and switch between different ways of rendering using symbology. And as we see here, we can manually improve and update using tools in ArcGIS Pro, certain building or feature classifications. And lastly, we also provide a suite of tools that allow you to convert the point cloud data into 3D models and even manually improve certain components of buildings directly from LiDAR and drone-based point cloud data. Now let's hand the presentation back over to Noel. Thank you.
Thank you, Jeff. And we have one last polling question for all of you. So it should appear on your screen momentarily. What is your interest in using the cloud software as a software for a service for drones? And we will give you a few moments to respond. And thank you for that. I will close this out and share those results. And it looks like some of you still need some information before deciding. So again, we will go back to Will, and Will will share with us some additional information that might be helpful.
Okay, thanks, Noel. So at this point, and Jeff as well, here is what I'd like to talk to you about, is catfish. I think that's probably what everyone was thinking would be coming up next, is catfish, talking about drones. This is a current research project that we're working on, and we work with a lot of natural resource agencies, and they're mandated to understand species stock and to manage them. And they rely on scientists such as our group to provide accurate and actionable data to inform their decisions. And one of the species we help collect data on is blue catfish. This is a non-native species to Virginia. It is native to the Mississippi drainage, but has been found all over the United States and introduced into those areas for lots of different reasons. But I want to talk to you about integrating drones, artificial intelligence, and boats to create a less slimy scientific project. So to give you a little bit more background, blue catfish were introduced in the 1970s here in Virginia for recreational fishing, as well as to establish a commercial fishery. This is a species that lots of folks like to consume, and the challenge is that when the species was introduced, it has changed the Chesapeake Bay ecosystem dramatically, and blue catfish now are the apex predator, or the top of the food chain in the Chesapeake Bay. And yep, that's right, they feed just as high as striped bass and other fishes. So our mandate is really to find out how many of this species are out there, how old are they, are there trophy fish still around, and because they feed on the top of the food chain, is there any concern for human health? So typically how we capture information about blue catfish was use a technique called electrofishing. This is a low frequency electrofishing boat that is putting off a small discharge, and we dip the fish, we measure the fish, we weigh the fish, and we put the fish back. And over time, we've collected thousands and thousands of individuals. And so the graph that you see there is a length-weight relationship. And so what you see there is sort of as a catfish grows longer, it gets to a certain length, and then it just kind of gets heavier. Kind of like me, maybe after Thanksgiving, I guess. But that sort of gives you an indication as to the types of research that we're doing. And this is a very hands-on approach. We physically have to collect the fish. So as you can see there from the image, there's a lot of fish. So I had an idea. I went to a Esri conference. This was the Fed GIS conference a few years ago, and I saw the video on the left there of AI process actually counting cars and that kind of stuff. And I thought to myself, man, this is a great idea. I wonder, since I have all of this video here, and we're doing things really the manual way of sort of, you know, counting individual fish. I wonder if we can create a process using this type of algorithm to count catfish, which I think is a much better thing to apply effort to than counting cars. Maybe that's because I'm a scientist, maybe I'm not a transportation person, so I apologize for that. But you can see in the video on the right, that is a ton of catfish. The low frequency electrofishing process only affects catfish. And so you can see the birds flying around. So I thought in the beginning, well, maybe we can just get some grad students and we can digitize these fish and count them up and things like that. And then, so it's really been quite a long process. But what we have now is, when I saw that video, this is sort of the process to work with motion inside your drone acquired data. So up until now, you've seen a lot of collect imagery, static. We can do change over time, sure, but what about many, many, many frames in a sequential video? They all have information. So the idea is to obtain the video along with your flight log, which records all of the orientation parameters of your drone at the time of flight, and then marry that, which we call multiplexing, inside ArcGIS Pro, and then use the deep learning tools within ArcGIS Pro and Python notebooks and ArcGIS Learn, and sort of create that, that artificial intelligence workflow. And this is the output of that. And so what you see here are the green boxes across your screen that are highlighting the individual catfish that come to the surface. This, folks, is incredible. This has saved hours and hours and hours, and you see the folks there are actually taking and measuring the fish and weighing the fish so that I can compare it to the actual length-weight relationships that we have. You can see all of the fish are getting ID'd, but not the birds and not other things. So this is a very, very, very cool process that's allowing us to provide more informed information and more accurate information. There's no way these guys can dip all these fish, so we're estimating population based on, you know, a lot of factors, and this allows me to take each frame, create summaries, and so I'm just going to fast forward through some of this video here. Folks, it's a lot of fish, and there's even some really big ones in there too. So you can see here the detector works. It picks up all the fish. Just going to fast forward here. So you're probably asking, what happens to the fish? Well, they only stay on the surface for a couple of seconds, maybe a minute or two, and you see some of them dive back down again. This process doesn't hurt the fish, and they can live to eat another day. And so I'm going to fast forward. And of course, the last thing, this is the culmination of this entire project, is to marry this full motion video paradigm along with a traditional GIS and to actually create dashboards. Now, dashboards are great, but this allows us to literally go in and count and size fish automatically. And so we still got some tweaking to do, but it's a really, really cool process, and one that we certainly have been the bleeding edge on quite a bit. You know, collecting a certain type of video footage and processing it a certain way and things like that. And if you want more information on that, this is my shameless plug. This will be a chapter, the Catfish AI project will be a chapter in the GIS for Science Volume 2, which I just finished writing. That chapter and book is due out electronically June in this year. And you can find out more about the actual work process and how we went through that algorithm. So with that, I'm going to turn this back over to Ben, and he can wrap up.
All right, great. Thanks a lot. So I'm just going to kind of wrap us up today. So we talked a lot about the power of drones for GIS. We did some basics of how you implement, along with some sample use cases, and I'm hoping you saw something in there that really relates to what you do. And actually, we talked very specifically about Esri's drone offerings. So as a reminder for that, we have our drone mapping collections that support individual drone operations. all the way scaling from an individual drone operation all the way up to large-scale enterprises. And that includes everything from flight planning to processing our data and creating products to disseminate out. And basically everything you've seen today, these great 2D and 3D products, elevation data, point cloud data, et cetera, that those can all be integrated in using this workflow. We got to see Kyle take us through an end-to-end drone workflow using those drone collections to create those products. We saw how to use Drone to Map and ArcGIS Pro together to do some of that higher level processing and the ability to work disconnected in the field. And then we got to see some pretty exciting motion imagery for science applications. Count those catfish and using AI to really help aid us with that kind of scientific workflow. We only have a couple minutes left, so I think we're going to go ahead and move on from the rest of the Q&A. Actually, looking at the Q&A, it seems like most of those questions have been answered. Just the only questions that came in right at the end there was around SiteScan's availability. So SiteScan itself is a SaaS offering and really only available in one cloud environment currently. So we'll just but you leverage it by logging in through password and through a browser on the internet. So hopefully that answers your questions and tells you how that actually works for working with SiteScan. So beyond that, if you do have any other questions, we're happy to have you send us questions via email, or actually even better is to go to our GeoNet page and continue the conversation there with other people that are on this webcast or maybe that already work in this drone space. With that, I'm going to turn it over to Noelle, who's going to just do the final wrap-up comments and close out our session. Thanks.
Thanks, Ben. So yes, please visit us on GeoNet if you have any additional questions or you want to engage with any of our speakers today. We also invite you to go visit or go learn more about ArcGIS drone collections by visiting go.esri.com/drone collections. And as I mentioned earlier, this is webinar 2 in a whole series we have for our national government users. Our next webinar will be held on June 4th, and it will focus on field operations and data collection. And then we'll also have another one on June 18th, capturing reliable data in the field. So both of those would be great options to attend. If you have any other questions and you want to contact us directly, please feel free to email me. My email is on the screen. I have also chatted to everyone these 3 links in on this slide, so you can easily cut and paste if you need to quickly access those. So thank you so much for joining us today. We are ending right on time. We are glad you spent time with us, and we look forward to seeing you again soon. Thank you. Bye.